Welcome back to the Deep Dive. Today we're getting into something that is really the engine behind so much of what computers do. We're talking about repetition.
Or as programmers call them, iterations.
Iterations. Loops. If you've ever wondered how a program can sort millions of items or, process a huge data set without someone typing every single command.
Then this is for you.
Exactly. This deep dive is for you.
That's right. And our sources today give us a really solid look at these fundamentals. So our mission really is to pull apart the mechanics of loops. We want to get into not just what a for loop or a while loop is,
But why you'd pick one over the other.
exactly, and how these little control keywords can totally change how your code behaves. I mean, getting this right is the real shortcut to writing good, efficient code.
And what I love is how our sources connect this to, well, to real life. It's
Yeah.
not some abstract thing.
No, not at all. Life is just full of loops.
Right. Your morning routine, making coffee, prepping dinner.
Or even, the cycle of semesters at college. Those are all blueprints for what we do in code. It's just a way to tell the computer, do this block of code over and over again until I tell you to stop.
Okay, so every loop, whether it's in your kitchen or in your code, has a kind of anatomy.
It does. There are basically three parts. You've got the prep work to get it started, the actual tasks you want to repeat, and then, and this is the most important part, a condition to make it end.
Let's use the analogy from the source material because it was perfect. Slicing a carrot.
Yes. Okay, so think about the preparation, the first few steps.
Step 1, get the cutting board.
Step 2, get a knife. Step 3, get the carrot.
And you only do those once.
Exactly. That's your setup. It happens outside the loop.
Then you get to the actual work, the repetition. The source lists, steps 4 through 7?
Right? Place the carrot, lift the knife, move the carrot a little, slice. That whole sequence is the thing you're repeating.
And then comes the crucial part you mentioned, the end condition.
Step 8. And it's so perfectly phrased. If you see only your finger, then quit.
A bit grim, but it gets the point across.
It does. Otherwise, if there's still carrot, you go back to step 4. And that decision to continue or to stop, that's the heart of any loop. Without it, you get
An infinite loop.
a dreaded infinite loop. Exactly.
So prep, task, and condition. That simple idea is the foundation for the two big players, the for loop and the while loop.
And all the keywords that come with them, for, while, break, continue, in, even those more advanced for.else and while.else pairs.
Okay, so let's break down those two major players. When do you reach for a for loop?
The for loop is your go-to for what we call definite iteration.
Definite. So you know the number.
You know exactly how many times you need to run it. It's for a known fixed quantity.
So if I have a list of 10 emails to send or I need to check the first 50 entries in a file,
Yeah.
I know the count going in.
Precisely. You'll often see it used with something like a range function, which just, generates a sequence of numbers, say, from 0 to 9 for 10 iterations.
And the sources mention the variable names I and J. What's that about?
Oh, that's just a convention. A shorthand. It stands for iteration. And it's just a clean way to have a simple counter that you don't need to use for anything else. A throwaway variable.
Makes sense.
Right.
Okay, that's for fixed tasks, but so much of programming is, well, it's not fixed. You're waiting for a user or a network connection.
And that's where the while loop comes in. It's built for that uncertainty.
So you use it when you're not sure how many times it needs to run.
Exactly.
Yeah.
Its execution is based purely on a condition. Is this thing still true? Okay, run again. It could run 0 times, or it could run 1,000,000,000 times.
So if for loose is do this 10 times, whileose is more like keep doing this as long as the password is wrong.
That's the perfect way to put it. And while loops are, they are foundational for some of the most critical tasks in programming.
Like what? The sources highlight input validation first.
Yeah, that's a great one. You can't trust user input, ever.
Right.
So you wrap your input request in a while loop. You ask for, say, an age. If they type blue, the condition is the input a valid number is false. So you just ask again and again until you get what you need.
And the other example was that countdown script. That one had a neat little twist.
It did. It's a great way to show how loops interact with the world outside the code.
So you have a while loop that runs as long as the counter is above 0. Simple enough.
Right. And inside, you just subtract 1 from the counter, and then you use time.sleep to pause for a second.
But the twist was about clearing the screen between numbers.
Yes. You use a command like os.system
Okay.
here. But And here's the insight. That command is different on different computers.
Oh, right. Mac and Linux use one thing, Windows uses another.
Exactly. The POSIX systems versus LENT. So the loop itself is simple repetition, but the code inside that loop has to have its own conditional logic, its own if statement, to figure out which command to run. It shows how loops often act as containers for other kinds of logic.
That's a great point. Okay, so we can set up loops, but sometimes you need to change the plan midway through. Let's talk about control, break, and continue.
These are your fine-tuning tools. They let you react to things that happen inside the loop.
Let's start with break. Using our carrot analogy, this is when you,
When you see your finger.
right. It's the emergency exit.
It's an immediate, absolute stop. The moment the code hits break, the loop is done. Over.
So the rest of that specific slice doesn't happen, and no more slices will happen after.
None. The whole thing terminates.
And the source has clarified something important here. If you have a loop inside another loop, a nested loop, and you hit break.
It only breaks out of the innermost loop. That's a super common point of confusion.
Good to know.
The outer loop just keeps on chugging along.
Okay, so break is a hard stop. What about continue? The source has called it the skip ahead,
Yeah, continue is much gentler. It doesn't end the loop. It just says, I'm done with this particular run.
this one iteration.
Right. It just skips the rest of the code for that one item and jumps straight to the top to start the next one. It's perfect if you're processing a file and you find a corrupted line. You just skip it and move on.
This all seems pretty straightforward, but now we get to something that honestly is a bit weird when you first see it. The else clause. On a loop?
Ah, yes. The for.else and while.else. This is one of those features that really separates beginners from more experienced programmers.
Because else usually goes with if. Why would a loop need an else?
Okay, so this is the aha moment. The else block on a loop executes only when the loop completes normally.
What does normally mean here?
It means it ran its full course without being interrupted. For a for loop, it got through every single item in the sequence. For a while loop, its condition naturally became false.
So, it did not hit a break statement.
That is the crucial detail. If the loop finishes because it hit a break, the else block is completely ignored.
Oh, wow. Okay, I see it now. So if I'm searching a list for a name and I find it and break out, the else doesn't run. But if my loop finishes the entire list and never finds the name, it finishes normally.
And the else block runs. So you can put your name not found message right there.
That is so much cleaner than using some, like, found it false flag variable that you have to check at the end.
It's incredibly powerful. It's a way of confirming that a process ran to completion without any exceptions or early exits.
All right, now that we have the theory down, let's talk about putting it to work. The sources gave some classic examples.
They did. First up was counting the digits in a number. A perfect while loop problem?
Right, because you don't know if the number is 10 or 10 billion.
Exactly. So you just have a loop that keeps dividing the number by 10, chopping off a digit each time, and it runs while the number is still greater than 0.
Simple, effective.
Yeah.
And then, of course, we have to talk about FizzBuzz.
The classic programming interview question.
It's the ultimate test of both loops and conditionals, isn't it?
It really is. The loop part is easy. You know you need to go from 1 to 100, so that's a for loop.
Easy. But the logic inside is tricky. You have to check if the number is divisible by 3 or 5 or both.
And the trick, the thing that catches people, is you have to check for both, divisible by 15 first.
Right, because if you check for 3 first, then 15 will just come out as fizz, and you'll never get to FizzBuzz.
It forces you to think about the order of your logic inside your iterative structure. It's a brilliant little problem.
Okay, so those are great practice. But for anyone looking to really push themselves, the sources pointed to competitive programming sites, like Katie's.
And the observation they made is, well, it's profound. Almost every single problem on those sites involves loops in some way.
They're not just a tool, they're the engine.
They're the whole engine.
The sources listed a bunch of problems. Let's take oddities. Seems straightforward.
Oddities is a pure for loop test. You get a list of numbers, and you just have to go through every single one, iterate over them, and check if it's odd or even. It's about processing a collection of data.
What about something a bit trickier, like sorta sort? The sources gave a hint for that one.
Yeah, sort requires more control. The hint says you have to print sorted items, but you have to skip an item if it's smaller than the last one you printed.
Ah, so you're iterating, but inside the loop, you're checking against a previous state.
And if the check fails, you'd use continue to just skip to the next number without printing, or you'd build an if statement to handle it. It's all about managing the flow inside the loop.
It really just drives home that iteration is central to everything.
So if we pull this all together, What does it mean? It means iterations are how you turn one command into a powerful, structured routine. We've got the for loop for when you know the count, and the while loop for when you only know the condition.
And mastering those control statements, especially that for.else or while.else, is what really levels up your code.
It absolutely is.
So you, the listener, now have the tools to think strategically about repetition. You can choose the right loop for the job.
And as a final thought to chew on, think about that while.else structure. Apply it to that input validation example. You have a loop asking for a user's age, and it runs while the input is invalid. How could you use while.else to handle two different endings? One, where the user finally enters a valid number and the loop ends normally.
And the other.
And the other, where the user just types quit and you use break to exit immediately. The else block gives you a perfect way to separate the success case from the bailout case.
That's a fantastic little challenge. It really makes you think about flow control.
It does. And for your next step, really, go look up one of those Katie's problems, oddities, or rating problems. Try to build the solution just based on what we've talked about. That's how you make it stick.
Until next time, keep iterating.